Okay, so this is a little, if you're watching this video, we just remembered to video. We just talked about statistical versus non-statistical questions. Let's look at the last one. So how much time do the students in my school spend on the internet each night? Okay. Why would it be statistical?
Because it's not one answer.
Absolutely. And your key word there is variety. If you have a variety of answers, then it becomes a statistical question. Okay? One answer, non-statistical. All right? So the next thing we're going to look at is how to find the mean. Somebody go back and read the definition of mean. Just read me the definition.
The sum of the numbers in a set of data divided by the number of pieces of data.
Okay, so let me remind some of you right now that I am recording. Okay? What he just said, the definition of mean was the sum of the numbers, which sum tells us we're going to add. So the first thing we're going to do is add, okay? And then it is divided by the number of pieces of data. So we're going to add, then divide. So we add and divide to find the mean, okay? So looking at this, we're going to add these together. So we have 5 plus 11 plus 23 plus 6 plus 12. Okay, that gives us 57. For those of you that I know the next thing you're going to ask me is how much work do I have to show? I need you to show two specific things, and here's why. Because if you and I get a different answer, I want to be able to help you understand why you got the wrong answer. And I need to know if it's an addition error or division error. So we want to make sure when we add these numbers up that we're putting the total right here. We are putting our sum right here. Okay? But 57 is not my answer. Alright? We're going to divide by the number of pieces of data. At this point we have 1, 2, 3, 4, 5. So we do 57 divided by 5, which will give us 11.4. Now, this is your mean or your average of these numbers. If these numbers were in order least to greatest, 5, 6, 11, 12, 23, would 11.4 fall somewhere towards the middle? Yeah. So that's why it's called a measure of central tendency. It's a measure of how close that falls to the middle of that set of data. All right? Let's look at the next one. To me, this one looks like a set of test grades. So we're going to add them together. Okay, guys. So we're adding them all together. And we get 601. Now, what are we going to divide by? 7, because we have 7 grades. So we do 601 divided by 7. Now, I want you to go ahead with statistics right now. We're going to get used to rounding to the tenths place. What number is in my tenths place? The 8. If we look right here, this 8 is in my tenths place. If I look to the right, that 5 tells the 8 to go up. Okay? So our answer would then become 85.9 or 85 and 9/10. Now, very important. If we look at these test grades, the lowest grade was a 62, the highest was 100. Does 85.9 fall somewhere towards the middle? Yes. If you go all 9 weeks and your lowest test grade is a 70, can you have a 60 average? No. If your highest grade is an 80, can you have a 90 average? No. When you are finding the mean and you get an answer that is lower than your lowest number or higher than your highest number, it is wrong. It has to be between the lowest and the highest. It has to fall in that range, okay? It can't be any lower than your lowest or any higher than your highest. Does that make sense? So if you get a number like that, you have to check the reasonableness or reasonability of your answer. And if it is outside that range, then you need to try it again. All right? Exactly. If you got your answer of 101, and really most of the time what will happen is I'll see people that go, oh, my answer is 601. Well, no, it's not. And at that point, what did you forget to do? Divide. Okay? So that's why it's good to go back and check to make sure your answer sounds reasonable. Okay? All right, so I'm going to go ahead and give you your classwork, and we're going to do some of them together. Will you give everybody one of those? We're going to do some of these together because I want to make sure we have a good understanding. Thank you. Okay. All right, when you're getting your classwork, on the front side, it's asking if it is a statistical or non-statistical question. Instead of writing yes and no, I want you to use the abbreviations we use. S for statistical, NS for non-statistical. Okay? On the back, you are finding the mean of those sets of numbers. Guys, if you give me just an answer, that's not good. I want you to show me what you get when you add up all the numbers. Tell me what you're dividing by and your answer. So that's your way of showing your work on that side, okay? All right, so let's talk about a couple of these because some of them are kind of up for debate. Some of them aren't quite as clear, and I want to make sure we can understand what would change making it statistical versus non-statistical. Look at number 1. How many cars are in each driveway on your street?
Statistical.
Why do you think it's statistical?
Because there's not the same amount. Because in my driveway, there's this person that has like 6 cars.
Right? Absolutely. Every driveway, thank you, may have a different number of cars. So this one clearly would be a statistical question. Okay? So that one would clearly be a statistical question. All right, look at number 2. How many people think Elvis is the best singer? Well, this one to me was kind of debatable because it's asking how many people, but to me it almost feels like you're going to have a wide range. You're going to have some people that say yes, some people that say no. So I do kind of feel like this would be statistical. Some people said non because it would be just a number, but I do agree. I think it would be statistical. Okay, what about how many boxes of candy did each student sell? Statistical, because think about it. You're going to sell a different number than somebody else. So you would have a wide range of answers on that one. Number 4, this is the one that threw me. How many cities had more than 2 inches of snow? It's asking for a number. It's not asking for a list of cities. So think about it. If you were to look at a map and it said how many of these cities had more than 2 inches of snow, it would be non-statistical because you're going to give them the number of cities. Exactly. So that's why I feel like it would be non-statistical. All right, last one. Now, this is the other one. How many girls are in your class? This means at one point in time, at one moment, so it would be non-statistical. Very good. Right now, we're talking about at one moment in one class, that number does not change. Now, if we were to say how many girls are in classes throughout the day, that would change. There would be a variety. But right now, at one moment and in one class, it would be non-statistical. Okay? All right, let's look on the back real quick. On the back. Again, what you're doing for each problem is you are going to add each set of numbers. We have 6 plus 15 plus 16 plus 20 plus 13 plus 5 plus 10 plus 16. So that gives us 101. Write that down. Divided by how many numbers? 8 numbers. So divided by 8. Yes, and we would round this to the nearest tenths. So the 2 tells the 6 to stay the same. 12.6. Okay? All right. Any questions on what we're doing? Good? All right. Tomorrow we're going to keep learning about the other measures of central tendency. We'll do mode, median, and then we'll also add range, which is a measure of variation. Okay?